Hello everyone, this is the Algebra 2 and of course review for Chapter 1, and we will be covering linear and absolute value functions. So one thing you need to consider when you're watching these review videos is that I am trying to condense weeks of Algebra 2 into a very short video. So keep in mind, I'm trying to hit the high points, and it's impossible to hit everything, and hopefully you remember a lot of the material throughout the school year. But let's get to it. Okay, you are introduced to two different types of parent graphs in Chapter 1. We have a linear function parent graph, and we have an absolute value parent graph. Absolute value is pretty easy to remember. You have to associate v in value with the actual shape of the parent graph. Take a note that the parent graph starts at the origin at 0, 0, and it has a domain of all real numbers and a range of y greater than or equal to 0. So quick reminder, your range is where it exists vertically, and your domain is where it exists horizontally. Likewise, over here, we have our linear function. It is automatically assumed that it starts right here at the origin, and it has an increasing as you read it left to right. So if you were going to reflect it, it would either flip over the x or the y-axis. It also has stretches and shrinks just like anything else would. The domain would be all real numbers, and the range is all real numbers. So there's no limitations on a linear function where there is limitations on an absolute value. You see how it keeps going all the way to the left at negative infinity and all the way to the right at positive infinity. But vertically, it starts at 0 and continues up forever, and that is why our range is limited in an absolute value. All right, so parent functions are really important to understand because a big part of Algebra 2 is you being able to transform a function, transform the equation, transform the graph, and let's take a look at all of the different types of transformations that we have. Translation is when you can move it up by adding a certain amount or taking away a certain amount to the function. If you were going to translate something left or right, what you would do is you would either add or subtract from the x coordinate or the x variable. So if you wanted to move something to the left, you would add to x. If you wanted to move it to the right, you would take away from x. If you wanted to reflect, you're either going to multiply the -1 to the entire function, and that's going to reflect it over the x-axis. If you're going to multiply the x only times -1, you're going to reflect it over the y-axis. Then you have stretches and you have shrinks. A vertical stretch or a shrink, you're going to multiply the entire function times that value. So you're going to stretch it if that value is greater than 1. You're going to shrink it if it's between 0 and 1. If it asks you about a horizontal stretch or shrink, that is going to wind up being multiplied to the x, and it is exactly the opposite of a vertical stretch or shrink. So if you multiply x by something between 0 and 1, it's going to stretch it, and if you multiply the x by something greater than 1, it's going to shrink it horizontally. Let's talk about equations. We have 3 equations that we've talked about, 2 for a linear equation and 1 for an absolute value. So the first 2, you're very familiar with this first one. This is slope-intercept form. So slope-intercept form is y equals mx plus b, where m is your slope and b is the y-intercept. The formula sheet does have the slope formula on it, so you don't have to have that memorized. The other form that we talked about was point slope form. You use that if you know the slope, which is m, and you know a single point, x and y, and you would plug it into the point slope form and then simplify if you needed to do that. The absolute value function is called vertex form of an absolute value function. And if you see, you have basically kind of a translated absolute value of x. So this is your parent function right here, the absolute value of x, and vertex function will have an a, it will have an h, and it will have a k. K will shift it up and down, h will shift it left and right, and a will either be a stretch or a shrink vertically. If a is negative, it will move that from a positive v to a negative v, so it will be like everything negative. If it asks you about what the vertex is and what the axis of symmetry is, I can give you a really quick example of that. So let's say I have a -2 absolute value of x plus 3 minus 5. I can clearly see that this has been reflected because of the -2, so it's going to face down. It's going to be a 2, so it's going to stretch vertically. I know that this has moved to the left 3 and down 5. So if it's moved left 3, it's going to sit at -3, and then down 5 would be -5. So that vertex is going to be at -3, -5, and the axis of symmetry is going to go right down through the middle of that. So that means that the axis of symmetry is x equals -3. All right, next up is linear regression, and we use that when we typically have a bunch of real-world data coordinates, or we have a table given to us. If they give us a scatter plot like this, then what you'll have to do is you'll have to translate that into x and y coordinates and type it in as a table. So you go to Desmos, you're going to hit the plus sign, click add table. On that second line, you're going to type in very specifically y1 tilde m x1 plus b. As soon as you type that code in, it's going to give you the slope and the y-intercept, and you're going to plug in the slope and the y-intercept right here, and that is your linear regression formula. Okay, and last but not least, we have piecewise functions. So piecewise functions are literal pieces of functions, and it's always determined by the domain of each part. So as you can see, this x minus 2 is only going to exist where x is less than or equal to 0. So if you look at this graph right here, it only exists when x is 0 and less than that. Same thing for 2x plus 1. It only exists starting at 0 but not equal to, and everything bigger than that. So I do want you to notice if it says equal to 0, it will have a solid dot. If it is not equal to, it will have a hollow dot. Things that you will be asked to do is recognize piecewise graphs, and you might have to actually plug in values depending on the domain. Over here, this is a piecewise function with 3 different types of functions. You have a linear here on the left, you have a constant in the middle, which is -1, and then you have another linear function here on the right. And you can see how it's pieced according to the domain value. You can also have partial quadratic and linear piecewise functions as well. Okay, when we do the examples, I want you to keep in mind that it's impossible for me to review all of the different types of questions that they could ask. There are hundreds of questions that they could ask just from chapter 1. So we're just going to do the best that we can with what we have. All right, starting with number 1. Clearly, we're not supposed to be using a calculator on this one. This is probably going to be a multiple choice, but in this example, we're going to short answer this. So it says graph the piecewise function. So what I'm going to do is I'm going to split this up into 3 domains. So x is less than -3. So I'm going to count 1, 2, 3. So I'm going to color that yellow. This is between -3 and +3. So -3 and +3 here. And then this one is going to be everything greater than 3. All right, so the only part of this graph that is going to exist is going to be 2/3 x plus 1. So to graph this very quickly, now I don't want you to copy this down yet because I'm going to erase part of this. My intercept is +1, so I'm going to put a little dot here. And then my slope is up to right 3. Up to 1, 2, 3. Up to 1, 2, up to 1, 2, 3. Okay. Now I'm going to go backwards. I'm going to go down to left 1, 2, 3. Down to left 1, 2, 3. Okay, now this is only supposed to exist in the yellow section, so I'm going to erase everything except for the yellow portion right here. I have to double check. Is it going to be a solid dot or is it going to be a hollow dot? It is going to be a hollow dot because it is not equal to. Let me go ahead and erase that. Hollow dot, draw your line. All right, let's do the blue section right here. So I've got the same intercept right here, but I'm supposed to go down and to the right, down and to the right, down and to the right. I'm going to go opposite until I hit my little threshold here. So these are both equal to, so I'm going to have solid dots on the ends of that blue section. Draw my line. Last one right here. This is not linear. It is a constant. So, I mean, technically it's linear because it's a straight line, but it doesn't have a slope. So I am going to go ahead and just find a point at -3. And it's just going to be -3 forever and ever and never always, okay? It's going to be hollow, though, and it's going to go to the right. That's how you do a piecewise function. Okay, question 2, or the next one right here, also does not have a calculator. What we're going to do is we're going to change this absolute value of x plus 3 to reflect all of these transformations. So if I wanted to move this thing down 2, I would take away 2. So final answer would be, and I've got to use g of x. It'll be absolute value of x plus 1 because I have to add these two together. All right. Next one says up 3. So if I want to move it up 3, I'm going to add 3. So final answer, absolute value of x plus 6, because 3 plus 3 gives you 6. Reflect over the x-axis. If I'm going to reflect over the x-axis, I have to multiply the entire function by -1. When I do that, that's going to become negative absolute value of x minus 3. You have to distribute the -1. If I want to reflect over the y-axis, I only multiply the x times -1. So I'm going to put a little negative right there in front. So that's going to be absolute value of -x plus 3. And I want to tell you right now, if you do that, that absolute value is going to cancel out that negative anyway. So you're not going to even see any changes at all. So it's going to look like this, final answer. Let me rewrite this. Okay. Vertical stretch factor of 3, just like when we reflected it over the x-axis, you're going to have to multiply the entire function by 3. So that's going to be g of x equals 3 absolute value of x plus 9. And then vertical shrink factor of 2/3, same thing, except for multiply by 2/3. So 2/3 absolute value of x plus 2, because 3 times 2/3 is 2. Okay, the next question is asking us to interpret the slope in context and to use the graph to write an equation in slope-intercept form. So slope-intercept form is y equals mx plus b. For me to write the equation, I need to know the slope. So easily enough, it actually shows me the slope here. All you have to do is think rise over run. You are going up 6 over 4. Remember, change in y over change in x, not the other way around. It's y over x plus b, and b is 0. So if I was going to simplify that, it would be y equals 3 over 2x, and that would be my equation. And if I was going to interpret the slope, I need to use words. So it would be 6 feet over 4 years. So you can say 6 feet per 4 years, or you can divide 6 by 4, and I do believe that goes 1.5 times. So it'll be 1.5 feet per year. All right, so on the end of course, they're definitely going to ask you about intervals, whether the graph is positive, negative, increasing, decreasing, and then they might throw in a end behavior question. So the easiest way to do this is to use highlighters. So positive is going to be above the x-axis. Negative is going to be below the x-axis. Increasing is going to be, if you're riding that roller coaster from the left to the right, you're increasing here and you are decreasing here. When I taught you, I would draw like little arrows. You just got to remember the arrows are going from the left to the right. We'll talk about end behavior in a second. So where's the graph positive? The graph is positive from negative infinity up to 2, 3, 4, 5, negative 5. And starts back at -1 and continues forever to positive infinity. So if they're asking about intervals, that is the x coordinate. Negative is going to be between -5. And it stops at -1. Where it is increasing, Where does it start increasing? It starts increasing here at the vertex. It starts increasing where x is -3 and continues on forever to the right. It is decreasing starting at -infinity, and it stops at the vertex where it's -3. And the end behavior, that is what the x does, what the y does as x approaches infinity and -infinity. So this is to the right. So x approaches infinity is to the right. Your y value is going up because it's positive. As it approaches -infinity, which is to the left, y is also positive. All right, use technology to fill the line of best fit. This is a scatter plot. So what you're going to need to do is you're going to need to write a table out before you use Desmos. So this point is 1, 5. This is 2, 4. This is 2, 3. 3, 3. 3, 2. This is 4, 1. And this one is 5, 1. So it doesn't matter what order you put the coordinates as long as the x and the y are matching. And let's graph it on Desmos. All right, so I have Desmos pulled up. I'm going to hit that plus sign, add a table, and I'm just going to type in all of my x values first, and then the corresponding y values. Okay. And then I'm going to type in my slope-intercept form, but I have to use y1 because it needs to recognize what's in the table. And then I'm going to hit shift to access tilde, mx1 plus b. So you see what happened here? It's giving us all of this stuff right here, and it says that my slope is -1.04 and my intercept is 5.7. So let's just round it to a few decimal places, and I'll write that down. All right, so I wrote down my slope and my y-intercept. So I'm going to write this down, -1.04 x plus 5.7, and there you have it. Okay, and our final practice question is evaluating a piecewise function. It says to evaluate g of 6. So you're going to have to pick which one that this is in. So where is x equal to 6? It fits into this category, right? So I'm going to plug in 6 into x plus 3, and that is going to be 9. All right, let's figure out where 0 belongs. 0 belongs up here. No, it doesn't. It still belongs up here in this greater than. So I'm still going to use x plus 3. So that 5x minus 1 is useless. 0 plus 3 gives me 3. That's it. That's all you got to do.